Hello again my friends, and welcome back to another BIM video. In this video I'll be presenting to you an introduction to the planning process involved when 4D BIM is implemented on a construction project. Just as a reminder, in a previous video when I introduced the dimensions of BIM to you, I had explained that 4D BIM involves linking a construction schedule with your 3D BIM model. In terms of what we're going to be learning in this video, I'll be describing what 4D BIM involves, the integration of 4D BIM with the topics framework that we had discussed earlier in a previous video, and then I'll talk about the scheduling approaches that are adopted when 4D BIM is implemented, and then finally we'll give a comparison of 4D BIM versus traditional resource planning approaches. It is important to understand that in order to use 4D BIM, you need to have the 3D building information model first developed. So once you have the 3D BIM, you can start implementing certain scheduling approaches to your model. All the scheduling approaches involve generating a computer model that allows you to visualize the progression of work on a construction site as time passes. A main point to consider is that the integration of the construction schedule and the BIM model is made possible through a link between the objects in your BIM model and the individual construction activities that are present in your typical construction schedule. Now let's have a look at some of the scheduling approaches that can be made possible via 4D BIM. First, we have project planning simulations, which involves simulating some of the conditions that are expected to impact the planning for a construction project, including site planning, transportation and site access, safety, and construction sequencing. Second, we have lean scheduling, which is a concept associated with minimizing time delays. A project can, for instance, be simulated considering just-in-time delivery of materials and machinery. Now, using this scheduling approach helps free up some space on your site, so reducing your inventory holding costs, and also allows the constant flow of resources required in various stages of the project. Another aspect of lean scheduling is associated with minimizing material waste. You can simulate a project to find out which activities use up the most materials and the quantity that will be required for you to order. This way you avoid over-ordering. Similarly, given the quantity of materials and availability of resources, you can also simulate the project and determine the required activities that need to take place. And this way you avoid overproduction on a construction site for a particular day. And as a result, you won't have to deal with, let's say, scheduling activities that require more resources than what is currently available for you to use. Finally, you can use 4D BIM as a means for visual validation of progress payments. This process can be further automated and securely performed if you decide to incorporate such a system through, for example, a blockchain. And this allows you to integrate other technology platforms as well within the whole process. Let me now refresh you a bit in terms of what we had previously discussed regarding the topics framework that I talked about. 4D BIM actually fits in perfectly with this topics framework. Specifically, it is used in 3 of the 4 components, namely the technology part, the organization part, and the process part. How is this the case? Well, in the technology part, you need to decide which 4D BIM platforms to invest in. Moving on to the organization component, your contracts will need to reflect the use of 4D BIM for simulation, for schedule determination, and for payment approvals. You may also need to coordinate with suppliers for material delivery schedules, for instance. In the process component, you need to decide on who you wish to train for using 4D BIM, who will be responsible for maintaining the 4D BIM files generated, and also who will assess the simulations that are conducted. Here is a quick example of a platform that was used for 4D BIM. What you see in front of you is a simulation that's conducted to choose an appropriate place for positioning a tower crane on site. Note that you don't have to design the adjacent buildings that you see. These can be quickly generated based on the footprints of the surrounding structures as derived from, say, maybe Google Maps or any geographic information system platform. The platform that's used in this example for 4D BIM is Navisworks from Autodesk. In order for us to appreciate why 4D BIM is effective, let us look at the traditional way of scheduling, specifically the approach that's used to plan and schedule resources on a construction project. In the traditional approach, reliance is on 2D diagrams, charts and plans. So many information tends to be missing. There is no direct link between the CAD drawings, specifications and the construction schedule in this traditional way of scheduling. Also, when using, say for instance, the critical path method, and it's a common scheduling method that's used, you fail to detect design errors, and as a result that leads to design mismatch. Spatial components that are associated with your construction schedule and that are related to resource utilization are not able to be adequately captured through that traditional scheduling approach. And as such, impacts of changes to the schedule on the resource utilization is difficult to assess. The scheduling process is also out of sync with the design. So if you had to make a change to the design, then it takes a while for you to reflect that in the construction schedule, and that can lead to inaccurate progress control decisions. Now the good news is that all of these points that I just mentioned can be accounted for when 4D BIM is used. Okay, so that was it for this video. I hope you now have a basic understanding of what 4D BIM is. If you did enjoy the video, make sure you smash that like button. In the next set of videos, we will explore 4D BIM a bit further. See you all then.